Now today's question is prove that root 5 is irrational. So we will solve this question by using the contradictory method. We have to prove here that root 5 is irrational. Root 5 is irrational. So what we suppose, let us suppose that root 5 is rational. So it means root 5 is rational. It means root 5 is equals to a by b. Now cross multiplying them, so it means root 5b is equals to a, squaring both sides. So when we squaring, we got 5b square is equals to a square. This is equation number first. It means 5 divides a square. If 5 divides a square, it means 5 also divides a. So we can write a is equals to 5c for some integer c. So it means 5b square is equals to 5c whole square. It means 5b square is equals to 25c square. So it says that b square is divisible by 5. So b is also divisible by 5. If b is also divisible by 5, a is also divided by 5, b is also divided by 5. So it is a contradictory fact that a and b have a common factor 5 other than 1. Means 5 is a common factor of a and b. But this contradicts the fact that a and b are coprimes. Hence, our assumption is wrong. So it means root 5 is irrational. Similarly, if we have to prove that like 3 plus root 5 is irrational, we have to use same method that root 5 is irrational as we proved above. Now irrational number is added with rational is irrational. So we can say that 3 plus root 5 is also irrational. Hence proved. Our next topic is terminating decimal and non-terminating decimal. Terminating decimal in which the denominator is going to be vanished or either is of the form in the zero like 10, 100, thousands and so on. And non-terminating where decimal is not going to be terminate, non-zero. For terminating it should be in the form of 2 raised to power n into 5 raised to power m. First, we have an exercise in which the questions are based upon without actually performing the long division. State whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. So for that, first question is 13 upon 3125. So for check whether it is a form of 2 into 5, factorize 3125. Then we should get 5 raised to power 5. Compare it with 2 raised to power n into 5 raised to power n. So we have 2 raised to power 0 into 5 raised to power 5. Here n is equals to 0 and m is equals to 5. But it is of the form n into m with 2 into 5. So 13 upon 3125 has a terminating decimal. Suppose we have second question like 17 over 8. So we can write it as 7 over 2 raised to power 3. It means 17 over 2 raised to power 3 into 5 raised to power 0. Remind that any number raised to the power 0 is equals to 1. That's why we can write here 5 raised to power 0. It means 1, and 1 into any number gives the same number. So it is also of the form where n is equals to 3 but m is equals to 0. So it is also a terminating decimal. Suppose if we have any number where we get another number other than 2 and 5, so it will be a non-terminating decimal number. Like we have number 64 over 455. It can be written as 64 over 5 into 7 into 13. Here we have 5 but 7 and 13 is also there. So it means it has a non-terminating decimal. Thanks for watching. Like it, subscribe it.